So hey, yeah, I wanted to talk about quality. Uh, who's familiar with the cover art on screen?
Yeah.
Cool. Yeah, so 25-ish years ago today, this game came out, Super Metroid. It's actually my favorite game. For those of you who aren't familiar, it's a side-scrolling adventure which is set in an alien world. You go around and try to stop space terrorists, known as space pirates, from developing and using bioweaponry. If that doesn't sound awesome, that's probably because I have undersold it. And if you're able to, please give it a try. The game was built as a partnership between Nintendo and another company called Intelligent Systems. And that was by a team of 17 people called Team Deer Force. Anyone who's ever worked cross-organization will know that it is, like, there is a lot of stuff that can go wrong when you're in that kind of setting, and this was definitely no exception. The game was quite late. Not that much by modern standards, but it was 2 years, and I think it was supposed to be less. And there were many logistical problems along the way, but team cohesion was never one of them, and they managed to build this thing, which is actually still stands up quite well today. Why this game still stands up is really relevant to my topic, because it is the same reason that many other Nintendo titles still stand up quite well today, and that is that Nintendo championed extensive software testing as part of a really high quality control process. This thing. It was actually this kind of process which helped them claw back the games industry in 1983 after an oversaturation of really, really low-quality games for the Atari 2600 almost killed the industry. Specifically, anyone remember E.T.? Or not? Yeah, it was a game that Atari published, one of the last actually, which sold so terribly that Atari then found themselves actually burying the entire remaining stock in landfill, where it's actually still there today. I'm not going to show you what it played like. It is not pretty, but it's a really good example of what happens when we skip any semblance of a quality process. At the other extreme, the quality process which led to titles like Super Metroid, actually I found it really hard trying to find out what that actually was. It is a closely guarded secret at Nintendo, even today. There are variants of it that are around for people externally to check, but they still do some stuff internally, nowhere near as vigorous as it used to be. But it is possible to make guesses by looking at the general state of software testing around at the time, especially in Japan. And it probably would have looked like a mixture of this idea called Kaizen, which is continuous improvement. That's something that Agile people are probably very familiar with. And this thing called total quality management, which is a really, really heavy topic that I'm not going to go into today because it's honestly very thorough. The resulting process would have been something that all of us would have been very frustrated with, though, because it would have taken a long time. They built it into the process, though, and it worked quite well. This is actually a still of E.T., and it's not nice. I love this example because it's like, on the one hand, there are these really exceptional games that are really engaging, like Super Metroid and other things. Pretty much every Mario game, good example. But then there are these really, really awful experiences that actually scared people away to the point where some of them never came back to gaming, which is why there was this weird crash in 1983. And it's really kind of what happens when a user tries to use our software and they are unable to use it. And I don't know if anyone's ever tried to use a shopping cart that's just not worked at all, but that's basically what this is. But maybe this is worse. Maybe. So with that out of the way, who am I and why should you listen to me? My name is Alex. I'm a full-stack software person. Primarily, I've built or have led teams building consumer-facing software, typically on the really safe area of the world called the web, where nothing ever really randomly goes wrong. And I'm just about getting a grip on this weird thing called quality, and I just wanted to share some thoughts. After this, hopefully you'll have an idea about why quality is important, why you can't really pigeonhole it, and why it can only really be owned by a team. The spoiler is it's because it's big. Hopefully you'll also have taken away a couple of ways of looking at and measuring quality throughout your entire delivery pipeline, and hopefully being able to measure it, you'll also be able to have a couple of ideas about how to improve it. Starting with the basics. Wow, that's glorious picture quality. What is quality? What is software quality? So there have been a few experts on the topic. These are three. I picked these people because they are considered to be founding fathers of quality, or at least that's what a process of, like a package of software quality testing tools owned by Motorola call it, called Sigma. William E. Deming, the guy at the top. So, also, this is, I don't expect people to read this. There's a lot of text on the screen. I apologize. I've been told off by people already about it. I just wanted to bring him up. William E. Deming says, the difficulty in defining quality is to translate the future needs of the user into measurable characteristics so that a product can be designed and turned out to give satisfaction at a price that the user will pay. This is not easy, and as soon as one feels fairly successful in the endeavor, he finds that the needs of the consumer have changed, competitors have moved in, and etc. Amand V. Wagenbaum, which I really hope I pronounced right, who's actually credited with that process I mentioned at the beginning, total quality management, says that quality is a customer determination, not an engineer's determination, not a marketing determination, nor a general management determination. It's based on a customer's actual experience with the product or service, measured against his or her requirements, stated or unstated, conscious or merely sensed, technical operation, or entirely subjective, always representing a moving target in the competitive market. That one is a really good definition because it talks about how quality is something you feel. It's not something that you can always measure, but obviously if you can measure it, you can work towards it a bit better. And then the final quote is by Joseph M. Duran, and he says that the word quality has multiple meanings. Two of these meanings dominate the use of the word. Quality consists of those product features which meet the needs of the customers and thereby provide product satisfaction. But also, quality is the freedom of deficiencies. Nonetheless, in a handbook, it is convenient to standardize the definition as fitness for use. That's awfully wishy-washy. So, reducing it a little bit, there are three main principles. So something can be said to be of high quality when it is fit for purpose, so it actually meets the requirements you expect it to do. It is serving a user need, so it's actually been built for someone and it's actually working to serve that user need. When it is free from deficiencies, so you can actually trust it to do the thing that you want, and when it's easily able to meet the needs of the future. So if your requirements evolve, you're actually able to actually adapt your product without having to rebuild the world. But this is still a little bit abstract, and I think I can do better. So it turns out there is a standard, several really, but there's this really hefty one called ISO 25000, or SQUARE, which is an acronym for Software Quality Requirements and Evaluation. It breaks things down into a set of high-level characteristics and lower-level sub-characteristics, where every single one of those sub-characteristics is a measurable thing. I'm not going to go through all of them because there's a lot. But I have used it as a sort of a set of themes for the ways that I would go about measuring quality. Those areas are functional suitability, performance efficiency, usability, reliability, security, maintainability, and portability and compatibility. The last two being ones that, honestly, I'm not that good at. So I also wanted to quickly touch on the fact that this is a huge area. So there is a lot of stuff to constantly be bearing in mind if you are trying to build something and release it. And typically people drift towards two ways of trying to ship. One of which is where you will identify that there's a reason, that there's a need for a quality process, and you'll bring some people in, or if you're really unlucky, you'll bring one person in. You'll give them all of this stuff on a plate, and you'll say, hey, please make sure that the things that we're releasing do all of this. And you end up with a group of QA people who will be having to test all the things. They will act as a bottleneck, and they will make themselves very unpopular very quickly. And then you end up with the other way of this sort of setup, which is the polar opposite, where people realize, oh, actually, we can automate all this stuff. Why do we need a person to go and check that we're still meeting all of these very abstract requirements? And yeah, that turns out to not work either, and your quality drops off just as quickly. So going over the actual areas of quality, there's functional suitability. This is an interesting one because this is that the thing that you are building actually serves a real user need. The definition I've adapted is a system provides functions that meet stated and implied needs when used under specified conditions. And yeah, how you actually go about measuring it is complicated because this is kind of a thing where part of it is how a user feels about using your system. I recommend using CSAT, which is customer satisfaction scores, which are a real way of getting the general sentiment of your product or thing. But also, I really recommend using a traceability matrix. A traceability matrix is it's like a grid, and on the one side you put out a list of requirements, on the other you put out a list of test cases and scenarios. And the idea is that you can identify gaps where you don't test for an actual requirement, and you can sort of see it very easily, very visually. I don't have any examples. So how do you actually go about improving it? Honestly, the easiest way, and this is the only one where I'll actually say this, is to hire a BA. There is no other good way of getting functional requirements down to a T, especially as something spirals in complexity. You need someone to be able to understand how to talk to all of the various people and get the right information to actually come up with functional requirements. And then actually work with a QA or a quality champion to actually figure out how you're going to measure this stuff. And then they can produce a matrix which will allow you to steer your quality. The other bit is implementing user testing. So actually going and talking to your users and asking if the thing you're building is good or if they're running into frustrations. And then you can kind of adapt based on that. This is where like a BA will also be able to help. I have an example for this, which is the time when we tried to, so we were given the gift of a platform, a product that needed to be migrated from one infrastructure to another. And it was not good because no one was around who actually knew how this thing worked. And we spent a lot of time trying to unpick the requirements, and eventually we got there. Going back, though, we would have preferred to have actually mapped out what we knew, mapped out the bits of the failing test suite that were already around, and used this to figure out what we would try to improve. It would have helped a lot on reflection, but hindsight and all that. There is this other area, performance efficiency, which is really performance and efficiency, which is the performance relative to the amount of resources that you have allocated to a thing. This is how well your thing performs both from an actual cost perspective. So if you're running a bunch of servers and they are sitting idle all the time, then that's really wasting your money. But there's also this sort of other side, which is that it also directly affects the feel of your product if it's really slow. I think everyone's probably experienced slow websites where you're just trying to do a really simple task and you're trained Wi-Fi and it just fails continuously. Here, there is, you can start trying to improve this by implementing user-centric metrics. I'll get back to core metrics in a sec. Where you identify the things that are actually important to your users and you focus on improving those. You work towards them, maybe you put them on a chart. So good examples are time to interactive, or one of my personal favorites is time to first meaningful interaction, which is where in a browser you check to see until the user actually performs an interaction with a web page that you consider meaningful. And this is something you completely automate actually using Lighthouse. Core metrics are something that you should and probably could get away with in every area of your stack. But the idea is that you instrument latency, so how long something takes to respond, request rate, so the actual number of requests that you are processing, and error rate. And then over time, you can, with these three measures, actually see if something is going wrong. And if you chart it, you can see it very visually, very quickly. This also helps you identify bottlenecks and problems before they impact your users and get rid of your revenue. There is also capacity, which is good to actually do load testing on, so actually perform real user level testing on a thing to see how much to see how efficiently you are using resources. This is really only achievable after you have a way of measuring your resource usage. And then I sort of also talked about, I thought I'd talk about resource utilization, which is where you are, where by actually using a tracing process, you can look at the various different steps of your application and see, okay, this bit where I talk to this API is using up all of my network interface. I'm going to improve that, maybe. So how do you improve it? Honestly, the easiest way of doing this is by getting things right the first time. So I've choose the right technologies for your real problem. This is that whole classic, don't use Mongo if all you're doing is reading very structured data and writing very structured data all the time. Pick the right thing, and it will actually scale quite well if it is a real tested solution. Instrument core metrics across your stack. So if you're dealing with microservices, or even if you are dealing with like a LAMP stack where you have a MySQL server and just a web server running PHP, say, if you independently measure these three areas, so latency, request rate, and errors on those things, you'll be able to identify where your bottlenecks lie on your system before you need to think about other scale problems. Load test under realistic scenarios. So if you need to build a thing with capacity for 100 users at peak, test with 150, because one day it will happen and you might as well preempt it. And it probably isn't that hard to do. There are services like JMeter which make this very easy to actually do. And then when you're actually working on this, link performance metrics to real business outcomes. This really helps because when you are focusing on improving this kind of performance, because it's such a feels thing, if you can link that to like that work that you did to cut down, if you can link that work that you did to cut down on the time that it took for a page to load to actual revenue, then you can really manage up very easily that maybe this whole performance thing you're doing is a good thing and you should do more of it. So the example I have here is actually really silly one. I inherited a product and it was slow, very slow. And for years, various different people had attempted to try and fix it by adding different types of caching to it and all sorts of other things. And on one of my first tickets with it, I opened up the tracing tool that came with it, and I was on the train with really bad internet. And I found that actually it was timing out randomly. And in the trace, which I already happened to have open, I could see that it was trying to perform a synchronous call out to an API. Which was not available because I had no internet at the time. But in production, this API turned out to be slowing everything down to that level. And with this kind of instrumentation earlier on, it would have been possible for any of the teams prior to have sort of identified that there was a problem there. The bit I didn't mention is that the teams working on it prior were very much under pressure and had very little time to actually look at their stuff. So yeah, I'm not saying that they made a mistake. It's just would have been easier to notice earlier. Usability, which is a very large area, and one of the weirder things that was changed between ISO 25000 and its predecessor. It includes a lot, but I've only picked out accessibility, user-friendliness, and operability. Operability has a bit of cross-cutting with maintainability, which I come back to later, because it's how easily you can look after a thing. But accessibility. So there's the idea that you don't want to accidentally remove access to your thing from someone who just really wants to use your system. So, for example, don't use a red background with green text on it, because then people with color blindness will just not see anything. For example. But you get this metric for free. There is a really good set of standards out there. I've just picked one, WCAG 2.1, which has become kind of an industry standard, where there are loads of tools that will actually do the testing for you, and you can automate it if you like to actually get this, and you can track it over time. User friendliness is an interesting one because, again, you're dealing with user perceptions. So again, I've put down CSAT. It's a good way of asking, well, you came to our system today, you wanted to try and do this stuff. How easy was it for you to actually sign up and use it? And if the answer is it wasn't, then you should look at that. But then there are other interesting metrics, which are the number of first-line support tickets that you get raised. So if you get a lot of first-line support tickets asking for help with a password reset form, for example, saying, hey, I don't know how to do this. I keep trying to put in a password and it's saying no. well, maybe the real reason is that the user experience that you're giving the user doesn't explain that they have to put in a couple of characters and a symbol, or maybe it's doing so in a really unintuitive way. But again, this is something you can sort of spot on your dashboards if you sort of see, oh, we got a weird spike after we made this change in support tickets. And it's kind of the same thing for user error rates. That's looking at this automatically versus at like an actual user action. So you get a bunch of people trying to publish some content, and you see that they are getting lots of errors. Maybe you look into why, because even though you're not hearing about it, doesn't mean that there isn't a problem. How you can improve it? Automate, really, accessibility testing. This is something that you can bring really early on into your engineering process. So as soon as you start building a feature, you can check to see that the HTML you're building is semantic, that it passes various standards, that you're actually meeting color ratios. And you're making someone else's job a lot easier as well, because no one is the gate sort of to this at all. Regularly conduct user interviews. So speak to your users, like actually speak to them. And if you are being held back from them, then whoever is doing the holding back should either speak to them or you should demand to speak to them, even if it's like just for sympathy reasons, so you can see them actually using your system. Test on real user devices. This is really easy to do, and it's the one that I am personally the worst at out of everything I've put on here, because I really don't enjoy using slow Android devices. But actually, for the £100 it would cost a company to buy a phone that I can then test on every now and then, that's not that big an investment, because it means that I'll spot a problem before a user does, or more like 50 users. And then invest in onboarding experience. And this is both for your engineering team, so that helps with the operability side of things, but also for your users. If they know that, like after they sign up, that they can go through these steps to be able to use your system well, then they will probably stick around longer. And like this is more a UX thing, I guess, but it's still something that as engineers we should probably be very wary of. And my example here is that I was doing some work in accessibility for a platform, and I added the support for multiple locales to pages, and like actually picked out as like best practice about how I'd actually go about doing this, and really looked at the user experience a lot with my product person at the time. And it turned out that after we released this, it didn't get any use at all. I got one, I think. Because we focused, it was just me and a product owner. We focused too much on building the user-facing feature of this user-facing side of this feature, and not at all at the actual administrator side, where people would have to go in and actually put some stuff in with a new locale, and basically the feature still gets no use today. And it would have been really easy to fix at the time, but neither of us were thinking about it. Reliability. So a component functions consistently under specified conditions for a specified period of time. The specified period of time bit is important here because you need to be able to measure it. So you have to define a start and end date to all of your metrics here. How you actually go about looking into this. So I picked out stability and availability. Stability is easy, but I picked out two bits. So there's uptime, which you can do as a percentage. And then there's number of reported outages. Uptime as a percentage is cool, really cool, but number of reported outages is way more important, because even though it might not be representative, it really represents your user sentiment, and so it both gives you the ability to sort of say, hey, I think there's a problem here, we should look into it. It also shows you really what the impact on your users is. If it turns out that you have like 50% uptime and 0 reported outages, then maybe no one cares about your product. Or maybe you just don't have people working during those times. I don't know. For availability, that's a bit more complicated. So the recommended metric here is mean time between failures, and that is a combination of mean time to failure, so how often you actually run into big problems, and then the mean time to repair, which is a really interesting metric because that talks about your ability to respond to an incident. So say if my website goes down every week on a Tuesday, and it takes exactly a week to do this. The mean time between failures would be a week, but the mean time to failure would be a week minus an hour, and then maybe my mean time to respond would be an hour. This is a bad example because if it's happening in a regular, if it's happening regularly, then you should also be asking why. But it's an example. How do you improve it? Netflix, very popular for inventing this idea of Chaos Monkey, the Chaos Suite. A couple of other people have taken it and really championed it now, and there's a lot more tooling out there. There's a very interesting service called Gremlin, which does this. The idea is that you want to try and break your infrastructure before it breaks on its own, because even if you've perfectly architected the system, at some point an EC2 instance is going to get shut off because Amazon had a random hardware failure or something. The idea is you want to build your system to try and be resilient to these failures ahead of time. And if you are able to preempt that, and especially if you are actually simulating that all the time, as Netflix do with Chaos Monkey, which just turns off EC2 instances, then you will be a lot more resilient to actually to actual problems. So, knowledge sharing exercises. This comes in two forms. One of them is actually making sure that the people working on your products know how it works. So if you've got a lot of very in-depth technical knowledge, share it. But the other side of this is when you have a production instance and you maybe have a write-up, and if you don't, then I recommend writing it up. Actually making sure that people are seeing the write-ups, the root cause analysis, and can actually understand what steps were taken, what went wrong, how can we prevent it from happening again, that kind of thing, which really helps. But then there are things that you can't control. So third-party APIs, for example, like the one I mentioned earlier. Here, if you implement SLAs on every single one of these things, so you actually monitor a service. So in a project I have been working on recently, we use a DAM, a digital asset manager, which is hosted as a service. And their uptime has been, it could be better. But we have an SLA with them, so we're actually able to track this over time. And they have their own pingdom account. It gets sort of monitored and put its own bucket somewhere where we actually review it over time. If it gets really bad, we'll have to ask questions about how it's being run, but for now it's okay. But there's this other idea of applying a circuit breaker. So if something is broken, turn it off automatically. So yeah, I can't think of a good example. Instrumenting applications and services. This comes back to that idea of core metrics. So I have a bunch of servers. They are, going down every now and then because of Chaos Monkey. But oh, look, this one it has a dependency on this other thing that another one is running. I will actually notice that if I have latency charted somewhere, because latency will, in theory, go up. And then investing in observability tooling. Observability is like starting to be a bit of a trend. Now it comes from this idea in electric systems theory called control theory, which is that because you can't actually see the state of a component all the time, you can make guesses about its internal state based on the input and the output. So with observability in software, and where this is kind of coming from, it's structuring logs in such a way that you can actually inspect the operations that are going on internally. And actually, I talk about this later on in maintainability, so I'll come back to that in a second. My example about reliability is yeah, I don't know if this is that alien to people, but it was very, very weird when it happened for the first time. We used Puppet to look after a series of systems. Puppet is a configuration management system for anyone not aware. And it made a mistake. Puppet Master made a mistake that I don't remember the actual cause of. I'm pretty sure that it was actually a human error that prompted this whole thing to happen, but from us actually looking at it, it was it all looked like it came from the Puppet Master. It deleted a production database, and after it was done, it deleted the actual instance that production database was sitting on, which was not good, really not good. But because we had invested so much in trying to simulate problems before they actually hit us, we were able to recover very quickly, and it took us about 2 hours. Most of that time was actually re-indexing a search index, because at the time we didn't have persistent indexes. This was only really possible because we had looked at trying to make this exact scenario happen before it happened. Security. This is an interesting one because you can't really measure security, but you'll know when you've messed up because, well, everyone will know. The idea is that there's kind of two arms to it in the definition. You want to make sure that when things are going well, people are only able to access the things that they have the ability to access. But more importantly, you want to make sure that when things aren't going well, people still can only access the things that they should be able to access. The best way of measuring something that can be considered to be security, and this one is contentious. I'm not a security professional. This is just from interacting with cybersecurity people and just general best practice. OWASP have this idea of a risk rating, which allows you to quantify risk. The idea is that you want to try and make guesses about who might be trying to attack you, the way that they will try to attack you, what that vulnerability actually looks like, and then what the impact of that vulnerability is on you. So the likelihood by the impact. So, for example, like a robot trying every single WordPress site it sees until it eventually finds one is much lower risk overall than, say, a APT40, the Chinese-sponsored group going after your data, like they did to Yahoo, I think. Where that impact is huge because they have a lot of very, very sensitive customer information. Yeah. I think that's right. There are other things as well that you can do, though, because you can model risk, but that kind of involves you knowing what to look at. You can make a couple of general assumptions when you're building something, and again, this is where you kind of want to try and do it from the start, where you look at the number of things that a person can do that are kind of logged in some kind of way, because this allows you to log their intent and then kind of like a response. This is really interesting if you're trying to look at a system around like what is exploitable, and the idea is that you want to try and have a trend going down, really. Integrity. So the easiest way to build a secure system is to not have anything that is worth stealing in it, and the best way of doing that is by making sure that you don't have PII or other sensitive data stored anywhere. PII, personally identifiable information, sorry, acronyms. So you can actually just count the number of places where PII is stored and hope that you have like a decline. Something that has been going on in a lot of projects that I've been working on is slowly moving PII to Salesforce, who maybe don't have massive, like, maybe that's not a great thing, but it's still taking that responsibility away from the systems that we're building and maintaining. And there are other things like it that are worth looking into. And then there's compliancy in general. There's a bunch of standards out there. PCI DSS is the one that I'm most aware of, which you can kind of just pick up, and there's a lot of good tooling around it already. How do you improve it? So, well, first of all, doing those things, but automating, really. So you can, Snake, you can start. So the biggest thing that will own your application, especially if you're in the JavaScript world, is like a malicious bit of code in one of your dependencies somewhere. You could never be aware of what's going on there all the time, so it's actually quite easy to buy a tool and to let it like scan that for you. They picked out something really interesting recently, where it was an NPM module that no one could figure out what it was doing, and it turns out that for one application only, it was a Bitcoin wallet. It would actually do mining. It didn't steal from you; it just mined, I think. Yeah, I didn't actually put any notes about that because it only just remembered. But yeah, it's something that you can automate. And by the way, Snick are not the only people doing this. There are other people who do this as well. So in PHP land, for example, Composer has started doing a thing now where you can install a package, it will check it against a database and say, hey, this thing's exploited. Vulnerability scanning of an entire system. So it's better to pay someone to do this, honestly, because you'll get different things out of automated systems and out of actual pen testers. And if you are paying someone to do this, you might as well go for bug bounties, where you're basically paying for any hackers who happen to be bored, who happen to be looking at your system already, to give you the information about how they owned you, instead of taking the data that they owned from you and selling it to someone else. from an automated system, you'll get a good example of like an automatically exploitable area. So something that someone could use if they wanted to, but the chances are would probably not be used. Whereas if you're paying someone to do it, you'll get very specific exploits back, like we managed to find that your search form was, we managed to inject some data into you. Then I've also put down moving from role-based access control to attribute-based access control. This is something that comes down to sort of when you're actually architecting your permissions framework. You want to try and, instead of defining multiple levels like admin, superadmin, and user, look at the actual responsibilities those people need and give them those responsibilities only. So say user wants to read some content, admin wants to write some content, and then superadmin wants to delete content. Like, give them those responsibilities, not just general groups. It allows you to be very, very specific about who gets and does what. The example that I have for this is where a robot hacked into a Drupal site that I was given to look at to extract some data. It had been owned many years prior, but no one ever noticed. And what it did was, every now and then, if you were a search bot, it would serve Cialis adverts to you, and that was all it did. It also did tell a remote server that it was doing this every now and then. So I guess if someone was seeing a lot of activity, maybe they would have come looking because it was ringing home and maybe made it worse. But it was preventable, and all that needed to be done actually in that case was upgrading Drupal. And then there's maintainability, which I think is the biggest area that I've kind of covered here. This is talking about that ability to react to things in the future without having to rebuild the world. And the measurements here are actually quite frustrating and complicated, but that's actually by design. So testability. This is the one that people normally think of as being all of quality control, but it turns out it's not. And popular metrics are code coverage, unit level code coverage actually in particular. But the things that people normally forget are scenario coverage and that differing from feature coverage. Feature coverage is looking at the actual features and looking at describing the behavior that goes through them and looking at how many things are sort of covered by this, by the testing you have around it. This is something that actually maybe would happen manually in a one version of the world. But then there is scenario coverage, which is actually going through and methodically checking every single set of states that can happen for a given set of behaviors for a given feature. And you kind of want to try and balance these because they add up to giving you like a great deal of confidence that your thing actually works. But again, you can't get away with just unit testing. Unit testing is great in this area, though, because just having that alone allows you people who are getting started with a code base or a product to actually get up to grips with it quite quickly by looking at how things have been implemented, and then also by not being afraid of making mistakes, because if you make a mistake, your unit, well, in theory, your unit tests will tell you, hey, you broke this thing. And if they don't, then that's a good area to actually write a test for. I put down understandability and modifiability. So understandability is how easy it is to understand what's going on. There's a real emphasis here on convention and trying to keep things simple. These are good practices to follow in general, but you can actually get tools to nag you to do this. Modifiability is a lot more esoteric. There's cyclomatic complexity, which is how many ways a bit of code can be evaluated. And then there's cohesion, which is how likely it is that things should be in the same class or in the same bit of your application. These are important because if you are looking at something and you're seeing methods that have absolutely no relationship to one another and they're in the same place, you might try to refactor it but find out that actually there was a tight coupling. Or maybe you're just looking at a long method that does a lot of stuff. It's really hard to understand that if you are new to a piece of software, which is why we have these metrics. The best way of improving these is to invest really heavily in your developer experience. I'll get back to that in a second. But to actually just automate parts of your code review. There are services you can buy. SonarQube is the big one, but Codacy is one that I've played with in the past, that actually look at these metrics over time and will make suggestions if you are increasing the cyclochromatic complexity of a function, for example. And then actually they are getting quite sophisticated, and they will tell you how as well, which is really, really nice. Lean on unit testing to improve developer confidence. So, it's kind of what I've already said. If you are looking at unit testing as the thing to stop someone from, it makes people braver because you're not scared of making a mistake anymore. I'll start trying to go a bit faster because I'm wary of time. Reducing the number of caching layers. So caching layers can be anything that stores some data. The absolute worst thing that you want in your application is to have a bunch of data that you don't understand scattered everywhere. So reducing that and making better use of it instead. I am maybe alone in this, but I think that actually you can get away with maybe only using HTTP caching because it is a caching mechanism that describes a whole lot of stuff that you want to do. And if you really get it right, you can maximize your caching performance like crazy. And I'm pretty sure there are other people who also have similar opinions about how much you can get from a single data store. It wasn't that long ago when people built LAMP and that scaled. And then again, investing in observability tooling. So you don't need to. Actually, I'm going to skip this one because that's covered by my example. We had a scenario where we had a set of persistent problems. Have a set of persistent problems because it's not entirely solved yet. This one's still ongoing. And in actually digging into our problems, we started looking into one area of the stack, but realized that actually it was a red herring the whole time. We started looking into our overall architecture and found that there was one area of our stack where we had never really probed for problems before, ever, actually. But because we'd never done that, the team overall was very unfamiliar with that area of the stack. And that area of the stack was actually Redis. We found that actually, just by looking a little bit more at the actual operations that users were doing, so by charting that when a user presses this button, this action's happening in the background, that was actually enough information for us to be able to understand how to replicate. But also, we found that Redis behaves very differently to how we expect it to, or at least the way that it's being configured is very different to what we expect. And actually, everything is asynchronous, but the application treats it as being very, very synchronous. And because this is a scaled thing, if you make a change on one server, it then has to propagate to other servers. But other servers think that it has already propagated. And so you see data in an inconsistent state. And this actually came about, this idea about what our problem was came just out of looking at our documentation and thinking, what have we not looked at yet? So that's kind of that example. The final two, I'm going to be honest, I have not got these right ever. And they are portability and compatibility. They're a bit abstract, and I think these are more important if you're building desktop software. There is a lot to them, but I don't think that the overall payoff is that high. Again, this is my opinion, unless you're very risk averse. So for me, I could build an application and deploy it to AWS, and I'd be pretty happy with that. But for people who are a little more risk averse, say a fintech company that wants to own their IP, that's not that. In that sort of form, you wouldn't want to do that, because then if AWS and you had a falling out or something else happened, you'd want to move away very quickly. That's what portability kind of amounts to being. Portability definitely makes it easier to test and reproduce problems, though, because you'll be able to bring a version of your thing up somewhere else very quickly, whether that's locally or somewhere else. I don't think that that's that important, because if you're doing AWS right, you can probably spin up another AWS stack if you absolutely need to. I've largely taken the same solution to both, though. I'm not going to talk too much about other things I've tried, because they haven't been successful and they have wasted time. And that is to enforce the sort of Heroku 12-factor app principles. And this is basically talking about removing state out of your application and basically trying to build this idempotent thing. And it's actually quite easy to do this with almost any kind of application if you're containerizing using a technology like Rocket or Docker. I have a couple of more practical ways of improving quality, which are not based just on these pillars of ISO 25000. And they are defining done, which is actually a very easy win for most people. Experimenting with your process, and this is actually a core arm of Agile anyway, so people probably are already doing it in some form. And then the other one is to test in production, which I promise is not as bad as it sounds. So you can't and shouldn't take a standard like ISO 25000 and say one day, okay, we're doing all of this stuff now, because you'll never implement it and you'll probably never get a good return on investment from it. So being dogmatic about it is pointless. What may make more sense instead is to take this overall area and pick a couple of metrics out from every area that are relevant to you and your users, and to look at charting that thing over time. Bringing that into a definition of done. So what do we call done? What is if I was to build a feature which is adding a button to a page, when can I say that that thing is done? And this is something that you as a team should own, this definition. And it should include your measures of quality, because really, is it done if it's on production for some people but doesn't work? So if you are doing this right, you can periodically revisit your definition and ask just a couple of questions. Ones that I like are, do our users and our stakeholders understand how done works? Like, do they actually know what they are expecting to see if we release something and say that it's finished? Do we think that this has helped us improve our quality? So this is, as a team, do we think that this is actually working for us? And then finally, do our users feel the same way? So it's very well if we think that we've picked out these great measures of quality, but for example, if one of these measures was reducing JavaScript bundle size, and actually it turns out that all of our users were internal using Chrome and they had a very fast internet connection, they don't care about that, and they're wondering why you're focusing on reducing bundle sizes when they can't even sign in. And this is a thing where you should lean on quality champions or QA people to try and help you understand how individual units of work will be tested. This overall principle is something called shift left testing, right? Yeah, it's not that hard to do, but it is a big shift for people who want to treat QA as a gate, as a quality gate. This brings me into experimenting and iterating, which is doing this overall process, but getting feedback from people all the time. So as you are making an dent in any perceived quality problems, people will start thinking, well, actually, you know what you're doing. Maybe we should listen to you a little bit more. So it's actually easier to manage upwards, that you want to implement more things and to just try new things. And this sort of applies with people in other areas of the business as well. So another team that I work on, they build a service which does image manipulation at scale. And by just talking to them about how that works for us, we've managed to get a lot of really good insight, both on how to use it better and also on, well, actually mostly about using it better. But yeah, so use a model of quality to identify the metrics that you care about and work on those things, and chart them over time, and chart them trying to equate them to business metrics, because again, this helps you manage upwards, and people understand why you're taking all this time to work on this weird abstract thing called quality. They have to be easy to understand, yeah, because otherwise people who don't do software full-time will not care. And then the final thing that I have is testing in production. So I want to start off by saying we all test in production anyway, because the first time you release some code to prod, it's the first time that that code has ever run in that environment before. And so even if we think that it works because we tested it several times in a QA, a local, and a staging environment, there may have been one misconfigured thing or one difference that was critical and really hurt our users. Now, the exposure of a problem to users in general is manageable, but that's kind of where I'm getting at. So instead of trying to work to build production to make sure that everything we release to production is safe, make production a thing where it's safe to make mistakes. So if you're working on fault tolerancy, and you can survive a couple of AWS instances going offline. Make sure that if your code absolutely malfunctions, you can continue running. So I've talked about feature flagging, so decoupling the rollout of features to the rollout of code. You want to release often, but you don't want to release a feature to a user when it's not working. So give yourself the ability to canary test it. So give it to a subset of users, even if that subset of users is just you, and the way you're canary testing it is by opting into a feature flag. There are tools that do this. You do need to integrate them. I think Launch Darkly is a good example if you have, if you are just getting started with this stuff and you've never tried it before. And then synthetic monitoring of critical paths and features. You want to know if a critical path or feature has failed because of a completely unrelated release, before your users do. And then this one's very, very specific to the web. JavaScript, if it fails in a web context, it potentially cascades and everything stops working. So make sure that you can degrade gracefully. Enhance progressively to make use of as many features as you have available to you, and then degrade in a nice way. And yeah, we're already doing all of this stuff every time we push to production anyway, so we might as well formalize it and maybe lean into it a little bit more. And this isn't something that really worked that well for people making video games 20 years ago, because when you committed something to ROM, it was committed forever. But gaming companies today are also doing some of these things and are feature flagging and are using data-driven decision making. So why shouldn't we? Yeah, thank you. I've run a little bit over. That's Atari still in a landfill. Yeah, any questions?
I had one specifically about scenario and feature testing.
Yeah.
Obviously, we all, majority of us will kind of know about automating unit tests and integration tests and all that sort of thing. Do you have any ideas how to automate scenario and feature testing, or is that really a manual thing?
The really unpopular answer is to automate for the web through something like Selenium or Cypress, like end-to-end tests of actual user interactions with your thing. You can go further and actually test the APIs that are serving those bits of functionality. So, for example, in PHP land, a really good tool for doing this is Behat, where you can define features and actually get it past Cucumber.
It's very easy to write Selenium tests and have them click around the place and do things, but how do you, is there a nice way to kind of automatically kind of link those back to your core business requirements? Or tools for that?
Yeah, Cucumber will help. Cucumber is the syntax, which is very similar to what business analysts think in. No? Oh. It's an answer, but no, it's not very easy to do this. This is kind of, again, a lot of what we're talking about in quality is perceived. So if there is a perceived improvement in trying this weird new process that you've said we want to try, then people will be more likely to allow you to do more of that stuff. But I don't think that there's like an actual great way of saying, just because we tested using this new methodology, we actually got a measurable return.
I mean, do you have any examples of
no. The best yields ever on testing that I've ever had have always been when with manual testing, whether that's in new projects or in old ones. But that's not to say that that's a good way of doing it. It's just my experience.
Okay.
Cool. Any other questions? Cool. I think that's 7 seconds.